Hello dear viewers. You see a prefabricated EMI sensor with two different inductors that are connected to the PC audio line input. The maps show an anomalous magnetic field. Signals are recorded using the Spectrum Lab program. Both audio channels are recorded as a spectrum of the selected section up to 24 kHz. The left half of the screen is the spectrum from the flat coil. The right half of the screen is the spectrum from the annular coil. Frequencies 0.03 to 0.3 Hz and 0.3 to 3 Hz. Wavelengths 1 to 10 million km and 100 to 1,000 km belong to geomagnetic pulsations. Frequency 3 to 30 Hz. Wavelength 10 to 100,000 km. Research in the interests of communication with underwater and underground objects located at great depths, hundreds of meters, is underway. Frequency 30 to 300 Hz. Wavelength 1 to 10,000 km. There is the main part of the electromagnetic spectrum of power networks 50/60ths of a Hertz. In this range are the frequencies of the US SeaFarer communication complex, 78 Hz, and the domestic ZEUS complex, 82 Hz. Created for unilateral transmission of information to strategic nuclear submarines patrolling in the waters of the world ocean. Frequency 300 to 3000 Hz. Wavelength 100 to 1000 km. In this range there are electromagnetic oscillations of the sound range, the so-called whistling waves, whistlers, as well as various interference from household appliances. Frequency 3 to 30 kHz. Wavelength 10 to 100 km. This range has also been and still is in demand in signal transmission systems for reference frequencies, accurate time and meteorological information. In long-range radio navigation systems, including alpha and omega systems, for the transmission of synchronization signals, emergency alerts, etc., while at the level of transmitting complexes. Often combined with communication complexes with submarines. Recording was carried out in Krasnodar. This EMI sensor consists of, from bottom to top, a ferromagnetic tray, on which neodymium magnets are installed with the south pole up, 19 assemblies of 12 thin magnets each, flat base of the ring coil frame 2.9 kOhm 2.5H. Vertical blocks of ferrite N87 over magnetic assemblies 18 pieces, flat spiral coil on the board 165 ohm 2 mH, 10 blocks of cool mu material, 12 U-shaped ferrites from material N87. 4 vertical ferrites made of H87 material. Biasing from below can improve reception by analogy with RF field detection by a permanent magnet-biased ferrite antenna. This area is located in the zone of an anomalous magnetic field, mostly positive, but the dynamics of its change is not known. Perhaps when the anomaly has a south pole, the sensor magnets will be co-directional with it, which will give additional amplification. These recordings can help you better understand the various methods of receiving electromagnetic fields up to 24 kHz. Below are links to various similar observations. Thank you for your attention.